Okay, so we have a data sufficiency version of a ratio question, and I'm trying to highlight a couple things in these statements, but let's review the question first. So the question stem itself is, a pet store has dogs and cats in a ratio of 3:2 respectively. How many dogs does the store have? So we're currently looking for dogs equals question mark. Okay, so we know dogs to cats is in a ratio of 3:2. And as we just reviewed in the last video, we think about that as being really 3x to 2x, which means the total, if you add those two together, is going to be represented by 5x. And if you look at statement 1 doesn't tell us anything about dogs or cats, but it does tell us that the total of dogs and cats, when you smash them together and include them in one number, is 25. And if we look at our ratio as we set it up over here, we know that the total is represented as 5x, which means 5x is equal to 25, which means x must be equal to 5. And if x is equal to 5, then we know the dogs can be represented as 3 times 5, and the cats can be represented as 2 times 5. And 15 to 10 is a 3:2 ratio that adds up to a total of 25. So everything ties out logically, and this would actually be sufficient. So sometimes when you're looking for dogs, even if they don't give you explicit information about the dogs, you can still solve it based on that multiplier. So the multiplier is the main focus on a ratio question. Statement 2 similarly looks like it's not enough information to most people. But if we look at our version of the ratio, which is 3x to 2x, and if I said the store has 5 more dogs than cats, well, that means dogs minus cats is going to be equal to 5. And a lot of people have difficulty writing this in the correct order as well. Some people will accidentally write 3x plus 5 equals 2x, which is obviously nonsense if x is positive because 3x is going to be larger than 2x. So to add 5 to it would only make it even larger. A lot of people make this mistake. I don't know why it is. Something about the wording. But the way I think of it is the difference between them is 5. The larger minus the smaller produces a value of positive 5. And 3x minus 2x is equal to x, which means, again, our multiplier itself is 5. And then I could plug that into this ratio and see that we had 15 to 10 for a total of 25. And in either of these situations, we are going to get a sufficient answer because we got the multiplier and we already had the ratio, which meant we could solve for the number of dogs and the number of cats and the total as soon as we got the multiplier. So the little things that they like to do on data sufficiency, they like to give you the difference between components in a ratio and ask you if it's solvable, and it always will be as long as you have a ratio to play off of. If they give you the total, again, you can always get the multiplier, assuming you have the full ratio. So these are two things that they can give you that don't look sufficient that actually do produce a sufficient result.